There's a fundamental and I believe potentially fatal flaw in the architecture of most modern AI products. We need to talk about what this means. We need to talk about the death of the API-only backend. This quote, well, it really gets to the heart of the problem. When you rely on third-party APIs for your core intelligence, you're creating this illusion of stability. But the foundation you're building on, it's just not your own. Let's be very direct about this. If your entire competitive advantage can be replicated by someone else with a credit card and an API endpoint, you don't have a product. So let's give this a name. We'll call it the rented land problem. Because when you depend on these external APIs for your core logic, you're introducing a basic fragility into your whole system. And that's both a financial and a technical problem. Think about it. Every single user action, every piece of logic, is now tied to an external cost that you just don't control. This isn't a fixed infrastructure cost, not at all. It's an unpredictable operational expense that scales directly with your usage, and it just eats away at your margins as you grow. Now, to really understand how deep this problem goes, we have to look at the numbers. The unit economics of a purely API-driven backend, well, they simply don't work at scale. Okay, let's break this down with some simple math. We'll look at a single very common user request, an AI agent that needs to take, say, 5 reasoning steps to figure out a response. So, for an agent to finish a task that has just 5 steps of reasoning, it can easily take 7 separate API calls. You see, each step, each tool it uses, each validation, that becomes another round trip to a third-party service. Now, if we just assume a pretty modest cost of 1 cent per API call, that single user interaction now costs you 7 cents. I know, it sounds small, but this is the critical unit of a deeply flawed economic model. So what happens when you're successful? What happens when you scale this to 1 million users, with each of them performing this one action just once a month? The cost just explodes to $70,000 per month for a single feature. This is that hidden math of failure. Your success, your growth, directly leads to costs you just can't sustain. And here's the most inefficient part. Look at where that money is actually going. 40% of it is just sending schemas for tools. Another 25% is just resending the conversation history over and over. 15% context from your database. Only 20% of the cost is for the actual intelligence you thought you were buying. And that's the core inefficiency right there. You are paying for this immense overhead on every single call. You're paying for bandwidth and context, not just for the computation. You know, the problems here aren't just financial. Users complain about speed, right? And developers, we often blame the model's inference time. But the real bottleneck is usually just the physical and network distance between your backend and the API provider's data center. Every single one of those 7 API calls is a round trip across the internet. That cumulative network latency, it's what kills the user's perception of intelligence. It's not a slow model, it's a slow architecture. So the solution here isn't a faster model. It's a fundamental architectural shift. We have to move intelligence to the same place where the execution is happening. And this isn't about some binary choice between local versus cloud. It's really about architectural discretion, making deliberate, strategic decisions about where each piece of computation should run to get the most efficiency. Let's consider something called in-process inference. Here, you have a smaller, specialized model running directly inside your backend's process. There's no API call. There's no network latency. The model and your business logic are sharing the same memory space on the exact same server. The result, you get deterministic, almost instantaneous performance. This all leads us to a much more sophisticated architecture. Let's call it the hybrid brain framework. The principle behind it is simple. Use small, local, cheap models for most of your tasks, and then reserve those large, expensive cloud models only for the things they do best. So your cheap in-process brain handles all the high-frequency tasks, things like data classification, input validation, simple summarization, and especially sensitive PII handling that should never, ever leave your infrastructure. Then you reserve the expensive cloud-based brain for tasks that require really deep, complex reasoning or advanced multimodal capabilities. You see, the strategic error isn't using powerful cloud models. The error is outsourcing simple cognitive tasks that can and should be handled right inside your own stack. This architectural shift, It represents something a bit more profound. It's a move away from being a simple renter of intelligence and toward becoming an engineer of intelligent systems. It's really all about taking ownership. When you own the inference process, you gain sovereignty. Data residency and compliance, they become your default state, not some complex negotiation with a vendor. Those external rate limits, they just vanish. And most importantly, your margins stabilize because you've turned a variable expense back into a predictable, fixed infrastructure cost. This marks a necessary evolution for all of us. We're moving from being API glue developers to intelligent systems engineers. The value is no longer just in connecting services. It's in orchestrating that interplay between silicon, memory, and models. The choice is becoming very clear. You can continue to build on rented land, subject to the economics and the limitations of others. Or you can build a lasting foundation. Stop renting intelligence. Start engineering it.